you can have distances. Okay? And I know that all of you guys have done distances before. You guys actually did last year something called the distance formula. Does that vaguely ring a bell? No. You guys had you had ordered pairs. You wanted to find the distance between A and B? You don't need graphs for this stuff. Distance formula? Now, within graph stuff, and I'll show you, if you're getting turned, shut off by the graph stuff, what if I told you that there's a really, really, really easy way to do this via a graph, without having a graph? It's exactly what this is. Yes. You guys all know what the Pythagorean theorem is, right? What is the Pythagorean theorem? What is it? Very good. A squared plus B squared equals C squared. All right? Guys. So we know that and I think you said it had something to do with triangles, correct? What kind of triangles specifically? What was it? Right triangles. Right triangles. So inside of a right triangle, okay, in right triangles, there's this thing called Pythagorean theorem. The Pythagorean theorem always works with right triangles. You have two legs, the sides that make up the right angle. Hypotenuse, it's close enough, And you have the hypotenuse. The hypotenuse is the longest side. It's the side that is across from the right angle. That's always your C value. The other two parts are the little a and little b. Those are called legs. Right? Now, what's crazy is that you don't technically learn about Pythagorean theorem until first or second section in second semester, but yet we utilize it a ton. For example, do you guys agree that if I have my right triangle drawn like this distance between this point here and this point here is some horizontal distance because it goes left to right? Okay. And do you agree that this point here goes to here is a vertical distance because it goes up and down? Okay. Now, on a graph, left and right are what values? Your x's or your y's? Good. And therefore, by process of elimination, what goes up and down? Y. So to figure out distances, you need to know how far apart the two y values are. How far apart are the two x values? Okay. So if I'm looking at this ordered pair stuff here, well, how far apart is 3 and 5? 2. How far apart is -2 and 8? 10. So what happens is that I know that if I'm going left and right, the difference between these two values of x is 2. The distance between the values of y is 10. I can use those numbers to figure out how far apart those two ordered pairs are. Okay? That's the C squared. Yeah. So 104 is your C squared. How do you then figure out what the value of C is? What would you do with that? Square root. Okay. You would press the button in the calculator that says square root. So you'd have the square root 104 and hit enter. And it would tell you your answer. Last year you learned it differently. Last year you learned it as a very long drawn out formula. Distance equals the square root. Change in x values, quantity squared, plus the change in y values, quantity squared.
Is that where we have our lines, guys?
Yeah. That formula is Pythagorean theorem. Here's your change in x values, your horizontal distance. Here's your change in y values. All I'm doing is how far apart is 3 and 5? 2. How far apart is -2 and 8? 10. And I use Pythagorean theorem to go. Distance formula is Pythagorean theorem. It's just hiding That's the distance for you. Okay? Kind of. But now you got a button and a calculator, so you don't have to worry so much about that. But with simplifying stuff. Okay? Is that great? Is that an easy way to remember that, Ms. Thorne?
Yeah, absolutely. So are they going to need that right now in this first chapter?
Not so much this first one, but when he saw distance and he started, he's like worried about ordered pairs, and it comes in a little bit here and there, but it's not crazy yet.
Yeah, the big thing is that you guys know that distance is a number, right? It's a measurement. Right?
Yeah.
Okay.
So what we're looking at here is,
That was okay.
I know, it didn't show up very well. If we have 2 points here, and this point on a number line is at 4, and this one on a number line is at 13, how far apart are they? What's that? We can make this math a little bit more difficult for you if you'd like. And they're all going, wait, really? Yeah. How far apart are they? 9. Okay, that's the distance between. It's a measurable amount. Okay. As we get into it then, if this is 9, at least the total distance from here to here, distance would be 9. Okay. Now let me think. Do you guys know what the standard size piece of the paper is? Was it 8.5 by 11? Okay. So going this way is 11 inches. You okay with that? You're right, it is.
Don't make him walk any more than
I need
he.
to stretch. I need to
Okay.
stretch. I need to stretch.
All right, you should be leaning up against the wall and stretching your quad that way. Right? That's what he needs to be doing.
Is that better? All right, once again, you agree that these 3 things have to add up to equal 11 inches. Okay? Because going across is 11 inches. Right? The only difference between this is that I took the segment, because remember it's measurable, the segment started at, stop, from here to here, from A to B, is 11, whole thing going across. I made 2 cuts, which means I have 2 other points. Call it C and D. Let's say, for example, from A to C was 2, and then from D to B was 3. What do you do to figure out the one in the middle? Okay, what do you get? Right. Right, so we're doing. What's happening is that you can take segments and you can add them together. If you know your total distance, other segments can be made up of other, like just more parts. You know, if you look at the cinder block on the walls, all the cinder block going around, each one of those cinder blocks is 18 inches lengthwise. So 18, you just kind of continuing on with your segments. All right? Yeah. So what we're looking at here is, can we take these values, and I know if the total distance is 11, I back out 2, and I back out 3, I'm left with 6. Okay? It's kind of a little bit of a fancy way of looking at, or it's a really simple way of looking at something that can be very complicated. Because when you're looking at those 4 points, are what? They're on the same line, so what are they called? Collinear, very good. When you have collinear points, each one of those segments can be added to each one to get a total distance. It's called segment addition. Okay? Segment addition allows us, let's see, where is it? Segment addition, don't mind the balloon here, allows us to take 2 smaller segments to add up to be the larger. Okay? From here to the door is 8 feet. I go 2 feet. How many feet are left? 6. Very good. That's segment addition, ladies and gentlemen. The idea here is, what are the 3 collinear points in this case? A, B, and C. So A, B, and C are collinear. So segment AB plus segment BC has to equal what? What segment? AC, exactly. The 2 smaller segments add up to equal the larger. Look at what's overlapped within those letters. What letter is repeated? B. Notice how it starts with from A to B, then from B to C. That one in the middle is your repeated part. That means that if you're going in order, the new segment that's created are the end parts of the letterings. Okay? It's a shortcut way to remember how do you write it out. So again, if I know that AB is 7 and BC is 9, what's AC? No, I did not. Thank you for reminding me. They made sure I didn't join. Is this Murphy guy? No. So they stuck me in band, where I could be really loud and obnoxious. What do you think I played? What is it? What would you guess that I played? You're right. Trumpet. I played the saxophone. What's that? The trombone? I couldn't do the trombone. I didn't know what's going on. But I played the sax. I started playing the saxophone when I was about 10. Trombone. Trombone is this. That's a trombone. All throughout high school. I picked, it's still in my basement, I still play it. Not as good as it used to be. Alright? Saxophone. Real fast, don't write this down. In your textbook, you're going to see things that are called definitions, postulates, axioms, theorems. Yeah, don't write it down. Postulates just means it's a little bit fancier than a definition. Axioms are a little fancier than those. Theorems are more important, but again, it's just wanted to show you what it meant, so you're seeing. So what's going to allow us to do is things like this. Again, this is really, 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 really easy. The idea here is that can we look at, excuse me, look at a diagram, follow through what are the things that they're saying, and then figure out what's missing. Oh, I forgot about that. Good idea, Mr. Strower. Part and whole.
So it's the part plus the part equals the whole thing?
Yep.
Because I don't want you to think you're always going to have to add, right? If we give you the 2 little parts, you'll add to get the whole thing. But in this case, you got the whole thing in one little part. So you did this in algebra, you even did this when you learned how to add and subtract. This is like a missing add and addition problem.
It is.
And so marking your diagram, you guys, is going to be so very important because we're going to go from this with numbers right into algebraic expressions. And unless you complete your diagram with all the information that's given to you, you'll be confused. You don't know what parts do I add, what do I subtract. So labeling the diagram, muy importante.
Y bueno, para su clase de español. Manja. Oh, her handwriting? Oh yeah, her handwriting is pretty good. You see this? I gotta put up that. It's gotta put up stuff. It's every day. So again, what we're looking at here, just like Mrs. Throw was saying, we have part, and the whole. Which one of those are you looking for? A part or a whole? Part, okay? So as you put it through, we know that the whole thing, this GH, is made up of F, G, and GH. I'm sorry. F. Bless you. Well, if the whole thing is 36, one part's 21, and we don't know the other part, can I just call it X? Sure. How do you get it by itself? Good. And I've heard everybody already, a bunch of people already saying that. You get 15. Right. 15. SMRT.
There really isn't technically anything called second subtraction because how do you know that you're always getting the same amount?
But again, if I know that
This is 4, this is 12. I put it together, I'm always going to get 1. This you could subtract it out, but it's more when you use that one's
we do that, we'll do that one with tomorrow, and then because I did that, really.
Anyone know why we're both wearing club shirts?
Yes, because the Cubs play tonight.
So actually
Today, but
Tonight.
But it's themed Thursday.
the math department's gonna be crazy this year, because, you know, we're not just a bunch of idiots. Well, present company excluded.
What does that mean?
So themed Thursday. So
We like, the
this
math department, we
theme,
all like to kind of be goofballs, I don't know if you've noticed that, so I call myself an idiot, self-deprecating. And then I just said present company, as in she's in our company presently, and she's not.
I understand.
so most of the people in the department having their favorite sport team represented are going to be wearing Cub stuff, except we have to harass Reyes,
Well,
right?
you guys, well, Steph's a Sox fan too.
Oh, that's right.
I mean, they can be Sox fans, it doesn't matter to me. It's fine.
It's all good.
Did you see Bill Walton did the Sox game the other night?
No.
Bill Walton was the color commentator with Jason Benetti. It was hysterical.
Was it?
It was great. Benetti's, yeah.
I got my, I got this when I went to the World Series.
Hey, nice language.
Oh, wait, what are my earrings? Oh.
Yeah, remember, nice.
Yeah, oh, that's so awesome. So good.
I got red shoes.
It's okay, it's okay. You're good.
Her shoes are Cubs.
My shoes are closed. I couldn't find my ring, though, my ring.
Oh, you should bring it. Oh,
I know.
I know.
Sam holds it.
yes, sir.
One of these days.
Sorry, we're just going off on tangents, not really paying attention to you guys, because we really don't
But
like it.
tangent
That's okay.
is a geometry term.
Yes, sir.
All right, second edition. Write that down in the back there.
Yeah, there's just technically nothing called that second subtraction. Just one. Because you've got the whole thing is 36. If this much is 21, how much is left to get to the whole
Plus
thing?
15 is 36.
That's what. Yes, my handwriting's awful. I promise I will try not to use bad letters anymore.
No, I'm just asking.
I like your ass stuff.
These are too easy. Well, here, let's do this. So, I don't know if you guys can figure this out. You probably don't need to draw this or write this out. But you gotta slow it down some here. Again, what we're looking at is, when you look at the diagram, they'll ask you a certain question, and you just have to figure out, all right, they're looking for the whole thing. So, again, this was really, really, really tough. I'm very proud of you guys figuring out that fast. 24 plus 12. I'm belittling that they can make kind of a bad joke out of some easy math for a change. So, so you have 36 and 21, shouldn't be so bad. But what I want to look at today is I want to start throwing in a little bit of algebra. And what I did was is I took some copies of some older problems, and I want to kind of walk you through how do we do some of these bigger picture style problems. I hole punched this, and that way you didn't have to try and draw it. Because some of these, there's one sketch in here in particular that's a little bit more difficult to draw if you're not quite sure. You know? As long as you can read your notes, that's good. Now we didn't have to draw all these pictures. So what I did here was, guys, what I did here is I started to piecemeal together a couple examples that I wanted to walk through. One of them, a couple we've already done, so I'm not worried about it. But I'm looking at the problem right in the middle. It says, in the diagram, points P, Q, R, and S are collinear. Okay? It says points P, Q, R, and S are collinear. It then says that PS is 46. Is PS a part, or a whole? It's the whole thing. So when you draw that, what I like to do is I like to draw it like that. Put the little two end pieces on it, those little bar pieces off to the sides. And then it says PR equals 18. So I might draw another smaller one in here. Okay. And then lastly it says PQ equals QR. Remember what we did with diagrams where we know that you have values that are equal in measurement? What did we mark them with? Do you remember? How did you mark your diagrams for things that have the same measurement? Remember we used it, yeah. Yeah, the little tick marks, exactly. If I put that there and there, that means that PQ has to equal QR. It's called a tick mark. It's called a congruency mark. Things are congruent if they're equal in measure. So if you have two things that are equal, and they have to add up to equal 18, what do those two things have to equal? 9. They both have to be 9. All right? Now, going back to the whole thing. We know the whole thing is 46. If I take out the 18, how much is left? 28. 28, good. So I know that RS is 28. Notice how we have not asked or read one of the questions yet. Whenever you have diagram problems that have multiple questions to them, don't read the questions until you work with your diagram. Because now when you read your questions, well, what's PQ? 9. What's QR? 9. What's QS? 9 plus 28? 37. And what's RS? 28. Once you fill in your diagram, then you go back to answer questions. Does that make sense?
Yeah.
Okay. That's kind of our first big, and it's not even a big diagram, but eventually we're going to have diagrams that have multiple bits of information. You can have 10, 12 questions off of one diagram with some of these things. The more that you go in and attack the diagram, if you will, by filling in as much as you can, the easier the questioning becomes. Okay. Yes, ma'am?
How did we get 28?
How do we get 28? So we knew that the whole thing was 46, and I knew that this chunk was 18. So what's left over? There you go. We just subtracted those two segments. Okay. Now let's take a look at number 22. On number 22, guys, you have L, M, and N. On number 22, it has that diagram. Using segment addition, we're going to write it out into an equation. So what is the first part value? Either one is fine. So if I'm reading it going from left to right, my first part is x. To that, what do I have to add? Plus 2x. And what do those two parts have to equal? The whole thing. Part plus part equals the whole thing. Just putting the algebra together. So what's x plus 2x? 3x, good. Therefore, what is your value of x going to equal? 6. 6. So x is 6, which means that LM is 6. MN has to equal how much? 12. So you're using the same idea of the segment addition, but we're throwing some variables in it. All right? Not that much difficult, is it? No. See what we kept saying about how the algebra stuff we're going to be using is just 1 and 2 step equations? Well, there it is. All right. Let's look at the next one. What are your 2 parts for the next one for 23? So we've got T, D, and W. Whole thing is 32. We have what, a 3x and an x plus 8. And then they're asking us to figure out what VW is at the end. So, how do you write this up as an equation? Yes, ma'am. Yeah, go for it. Erica. Everybody hear her okay? 2 smaller parts add up to equal the whole. And then from there we just start combining like terms and solving your 2-step equation. And it falls back into the same level of algebra we've been working. We have 4x plus 8. Subtract the 8. Excuse me. We get, what is that, 24? Divide that out. Okay. Yeah, so from here then, the only part that was asking you to solve for, and this is a very common theme within geometry, it's not just solve for x, it's solve for x and do something with it. In this case, the do something with it was asking us to figure out what is VW. Well, what's 6 plus 8? There you go. And if I had to find the other side, it would have been 18. And if we math it correctly, 18 and 14, if you add them together, you should get. And this is, with this style of stuff, I like how you use logical because it is very logical. Like, well, this, they're all in the same line, so it has to add up to equal this chunk. This one plus this one equals the whole thing. All right? Take a second and try the number 24. Good on time. No, I was just saying, I was looking at how we're doing the time, just trying to figure that out. 24 real fast. Take a second to look at 24. I want to. Man, press like that, right? All right, let's see how we did real quick. We're running out of time here. So we have, if you did this out, 2x plus 3 plus 3x minus 1 equals 27, I believe. Yeah. All right. Combine your like terms, you get 5x and a 2 equals 27. Subtract 2. and you get x equals 5, oops. But then it asks you to figure out what is the value of yz.
Oh, I think it.
So you substitute it back into the yz portion, you get 3 times 5 and subtract 1, and you get 14. Excellent. All right. So all I want to do tonight are some... Good. It should be. I'm hoping it is. All I want... I'm not going to... Don't lose this one, so we're going to use these... The ones below that, we'll use those as the start of some of the stuff we're going to look at tomorrow about how do you draw your own pictures. But what I want to do are these today. Yeah, save that for tomorrow. Done. You sick? I want to lose it. What's that? So, you're welcome. My guess is that these 10 questions shouldn't take you any longer than maybe 12 minutes. Okay? I know. If you look at it, the only thing that's a little bit different, I want you guys all to take a look at number 7 really fast. On number 7, there's a couple of them that look like this. If you look at number 7, the whole thing isn't a number, is it? It's still an algebra expression. Even though that every part within here are variables and pieces, you're still doing the same basic idea. If I put 2x minus 12 plus 10, it has to equal x plus 5. So we're going back to what we were looking at before, where you would wind up with variables on both sides of an equation. That can happen, and that's okay. So you start simplifying it out. You get 2x minus 2 is x plus 5. Variables on both sides of the equation, what do? Yes, sir. Negative 12 plus 10. How do you move, or we'll pick on the little guys, so we'll subtract the x. At the same time, I'm going to add 2 going back. I get x is 7. But then, what was it asking for? I mean, yeah, you can substitute all and make sure it all works, but it said find WV. So WV, when you substitute in for 7, 2 times 7 is? 14. Subtract 12 is? 2. I just want to make sure it showed you guys an algebra style that still looks like stuff that we've done. Yeah. And then the last 2 on that sheet, there are 3 sections. Instead of adding 2 together, you're going to add 3. Pace yourself. Please pace yourself. You're going way too fast. I don't want you to blow on me like how's your foot feeling today? Better? Ish? See you guys. Oh.